line to read in a name or read in or anything that has a space in it if you're dealing with a string. You have the C and the get line. Get line and the CN. You're gonna input a wage. You're gonna input hours. But when you print them out, the wage is gonna have 2 decimal places. Hours gonna have 1 decimal place, and the gross pay going to be this time this to give you this with the 2 decimal places, and then the taxes going to be a percentage, whatever the percentage I gave you, 17.2% of this, and you should get the point, the two decimal places, and then your net pay is going to equal to your gross pay minus the taxes to give you that. All right, so that's number 2. And I want to output it, and I gave you the column widths, and I gave you left or right or whatever. Well, you can see this is to the right, all this is to the left. And the very first one, program, you are to find, let's see, enter 3 values from the keyboard, all right? So you input the 3 values, and then you should output the product of whatever the number, comma, whatever the number in a comma, and whatever the number space is, and then whatever that result is. So you have a variable. You're going to read these into variables, maybe have a formula to calculate and store the variables to output. All right? So, and it just give you an example of what it should look like. All right. So you read it, get the product. All right, and then it say if 3, 5, and 7 is in it, you should output this. Then the number is odd. Else, if it's not an odd number, then you output the product of whatever is even. And make sure you follow the output scheme. Some people try to create their own, and like I said, I take off because I give you what I'm looking for. So make sure you follow that. All right, so nobody have any questions about the assignments, okay? And they do what? By tonight, okay, do by tonight. Now, I didn't go in and kind of scare you this time and put 0, 0, 0, 0. And go, Ms. Best said do tonight. I just gave you the date. So, let's go to chapter 4. Now, chapter 4 is dealing with making a decision. And to do that, most programs use an if statement, all right? This if statement. So you can use an if to where you can ask the question. Am I sharing my screen?
Yes.
Okay.
Yes, sir.
All right. Most time, well, there's several ways you can ask a question. You could ask the if. Say you could ask the instructor if I pass the class, okay, and or you could ask if I pass the class, can I whatever, or can I whatever. So you ask a question as to if or else. So that's some of the things you can do in computer science. If the cost is greater than 5, do whatever, and then just continue. Or you could ask, if the cost is greater than 5, do whatever, else do this. So now you got a choice as to what you need to do, an if-else statement. But then also with if statements, you can have nested ifs, all right? You can have an if within an if. If x is greater than 5, else if y is less than 3. So now you got one if, and if it's true, then you fall into the question for the second if, okay? Now, so just to give you a brief discussion of what it's about, but then they got the switch statement, which also somewhat does the same thing. You know, you can ask, okay, this, if this, if this, if this, if this, do this, if this, do this, if this, do this, otherwise do this. So let's look at this chapter. And first it starts off with these relational operators. A relational operator operators allow you to compare numeric and char values and determine whether one is greater than, less than, equal to, not equal to another. Okay, so let's look further down. These are your relational operators. Okay, greater than, if x greater than y, less than, if x less than y, greater than or equal to, if x is greater than or equal to y, less than, if x is less than or equal to y. Uh-oh, these two equals, what does this mean? Well, this is a comparison. If y equal x. Now, the thing is, many times students get confused with this and just x equal y. And I'll just pull this up. Okay, if I do this, int x, comma, well, x equal 5, well, equal 5, comma, if I could type 5, comma, y equals 3. All right. If I do something like this, and this is the format normally, if x is equal to y, what I'm doing, I'm comparing x to y. Whatever the value of x is, compared to whatever the value of y is. If they are equal and that yields true, then I want to do something. I would do something like this. I'll just do /t. Yes, x is equal to y. All right. Okay, so now, so it's if I do this, if I run this program, x is 5, y is 3. So if x is equal to y, is it? No. So it won't print anything, right? So if I debug it, well, let's run it. It's going to debug. Yes, I'm going to. What happened? Oh, this is not it. Let me run it again. Okay. So look, I got no output. There's no output because what happened? It asks if x is equal to y, do this. But now, watch if I do this and make this 5, and then I'll run it. Oh, yes, x is equal to y, all right? But what I'm gonna do, I'm gonna change this back to 3, right? So it's not equal, so we what? We shouldn't get anything. So when I run it, we get nothing, all right? Just a blank screen. Now, this is the mistake some students make when they first start coding using the if statement. They'll do this. If x equal y. When you use the single equal, you are actually assigning y to x. So what you're doing is, in this case, you're assigning x to equal 3. So if x is equal to 3, that's true. Because if I'm going to assign it to equal 3, and ask if x is equal to 3, you know, well, it's not even asking. It's assigning x equal 3, and then it's continuing. So when I run it, it's going to say, yes, x is equal to y. So watch what happens when I run it. See? Yes, x is equal to y. But the only reason x is equal to y is we assigned the value of x to y with that single equal. And if I just go back in the program and I just put the double equal, which is the logical comparison, now it's saying if the value of x is equal to the value of y. And now that would be no, and I will not get any results. So you see what I'm saying? So that double equal is the logical comparison. And you got to keep that in mind because, like I say, students get headaches by trying to figure out, well, why is my program doing this? I know I'm writing the code right, and it's just a simple equal rather than an equal equal. And then we have not equal. The exclamation point stands for not, all right? So if I have two numbers or two variables, I could say if X not equal Y. So that means that they're not the same value, okay? All right? So, and like I say, these are all the logical operators, all right? So basically, that's what we're going to be using. X greater than Y, X less than Y. And like I said, this is why you kind of need to know somewhat about your math and how your math operators work. Because in computer science, you're going to be dealing heavily with if statements and using these operators and determining whether something is true or not. All right? So it just gives us this, and we went over it, X greater than Y, X less than Y, X greater than equal to Y, X less than or equal to. Now notice in this one, you got the greater than symbol, then less than. I mean equal. Greater than or equal. This one, less than or equal. All right? So like I say, those are the way you use those symbols. This is the comparison, equal. And this is not equal, okay? So it says how a relational expression is used in the program. Remember, all expressions have a value. Relational expressions are also known as Boolean expressions. And that means like if X is greater than Y, it's gonna look at that and give a result. Anything that's one or positive would be true. Anything that's zero, well, anything other than zero is true. Zero is false. All right. So, which means that the value can only be true or false. If X is greater than Y, the expression X greater than Y will be true. Okay. While the expression X equal Y, all right, will be false. All right, and I'm gonna see where they get these values from. Where they give the values? Did they give values? See, I don't know why. Oh, they get. Well, where did they get the value? So they must have gotten the values from up top to say that it's true or it's false. But like I say, it depends on what the value of X is and what the value of Y is. All right. So, and here we go. The equal. I need to get this out of the way. Here we go. So now the operation, the equal operator determines whether an operand on the left is equal to an operand on its right. Okay. If both operands has the same value, okay, the expression is true. Assuming that A is 4, the following expression is true. A is equal to 4. That would be true. But the next one, A equals 2. That would be false. It says assume A is 4. So 4 is not equal to 2, so that yields a false. All right? So, and it tells you, it warns you about the equal and the equal. Because if I change this to A, 1 equal 2, that will be true. You know, I'm assigning 2 to A. So it's like A is being assigned to the value 2. So you got to watch, okay? Now, a couple of relational operators actually test for two relationships. And we looked at that. And you should know it from math. Greater than or equal to. If a number is greater than or equal to. If a number is less than or equal to. So if the number is less than or equal to that number, it's true. If it's greater than or equal to that number, it's true. All right. So either way, you know, you can use the less than and greater than for as operators also. All right. Now the not. All right. The not. If I had A equaling 100 and B equal 100, and I ask if A not equal to B, that will be false because they both are equal to 100, so they are equal. Right. So it tells us the last relational operator is the not equal, which is the which is the not equal operator, which I just said. It determines whether the operand on its left is not equal to the operand on its right, which is the opposite of what? The equal, right? And sometimes you may want to or have to do it that way because you're not looking for the equal value, you're looking for what's not equal, okay? Now, as before, assuming that A is 4 and B is 6, A not equal B, that's true, all right? But then, and C is equal to 4, B not equal C, that's true, because what? A is 4, B is 6. B is 6, C is 4, all right? So both of these are true, they're not equal. But then if we look at this one would be false because A not equal to C. 4 not equal to 4. No, that's false. 4 is equal to 4. All right? So you got to watch that. Now, it just show you the expressions and tell you true or whether they true or false or not. Assuming X is 10 and Y is 7. Is 7 less than, 10 less than 7? That's false. Is 10 greater than 7? That's true. Is 10 greater than or equal to 7? That's true. Is 10 less than or equal to 7? That's false. Is 10 not equal to 7? That's true. So you understand how I read it? I just put the values where the variables were and read it out like you're reading a mathematical expression, all right? But you as a programmer, you're going to have sometimes you may have an outstretched if X greater than Y and Y less than Z and T greater than 5 or C not equal to 3. So, you know what I'm saying? You're going to might have a long outstretched expression that you have to evaluate. And we'll look at how that's done. You know, you go from the parentheses outward, and then after that, you do each one, and then collectively you should have this compared to this to get a result. All right? So what is truth? All right? The question, what is truth? Okay. Now, what happens is we have a truth table. But let's look at this, though. What is truth? The question, what is truth, is one you would expect to find in a philosophy book. But like I said, in computer science, you're going to be doing it because you're going to run into, if you're programming or coding, many scenarios. When people code games, what? If they go to this location or like they hide behind a rock, if they shoot, and if they get shot, if the energy is less than whatever, then color code the bar or whatever. If they run out of bullets, if they whatever. So all those things you're gonna have, whether or not something is true or not, and then what you want to do based on that. If this button is pressed, how high, and they jump, how high they jump. If they jumped high enough to whatever. If they hit by whatever. Whatever, all that, like I say, is based on if logic that you will have to write as a programmer. So it tells us it is a good question for us to consider, though. Okay, if a relational expression can be either true or false, okay, how are those values represented internally in the program? Okay, how does a computer store true in memory, and how does it store false? Okay. As you saw in the program, we didn't look at it though. The exact state are converted into numbers, and we talked about the 0 and 1. 1 is true, 0 is false. All right. If expression yields 0, that means it's false. And if expression yields true, then it's true. Because really, you can even output an expression. Let's see if I could do this. If I do it, see out, can I go X greater than Y? All right. So I'm asking if X is greater than Y. I think I could do it that way. All right. So All right. So here, when I output whether or not X is greater than Y, I should get what? A 1 or a 0, true or false. Now, is X greater than Y? Is 5 greater than 3? True. So I should get a 1. So when I run this, everybody see? If logic, what? 1. So what? X is greater than Y, all right? And if I turn this around, if X, if I could type, less than Y, now is 5 greater than 3? No, so that's your false. So when I run this, I should get 0. But where is it? That's it. See, I got 0. If logic and X less than Y, no, false, which is 0. So you understand what happens. The computer, when it looks at an expression, it will determine whether it's true or false, and it will assign the values either 0 or 1. All right? So you got to keep that in mind. That's how the computer looks at it. We look at it as being true or false, but the computer just look at it as being either 1 for true or 0 for false. All right? So that's how it is it's done in the computer. So if we look here, pretty much the same kind of idea that we had, but what they did, they just assigned X less than Y to a variable called true value, and Y equals X to a variable called false value. All right. So X is 5, Y is 10. Is X less than 5? That's true. So it printed the 1. Is 10 equal to X? Is 10 equal to 5? No, it's not. 0. False. All right. So you see how that works. Now, look here. So what in here they just assign, they just give some examples. All right. X is 10, Y is 7. All right. So 10 less than 7, that would yield what? 0 for false, right? 10 greater than 7, that would output true 1. All right. Now, what that is, 10 greater than or equal to Y, that would yield 1. 10 less than or equal to Y, that will be false because 10 is not 10 less than or equal to 7. That's false. And then look here, 7 not equal to 10. That's true. That's 1. So those expressions, what they did is assign the value to Z here, assign the value to A here, assign the value to B here. Okay, in this expression though, C out, it just outputted the value, would output the value. It would just output the value. All right, but it still would generate whether or not it's true or false. All right, so that's what the computer does. But now let's look at the logic, okay? Now, when we've been dealing with programs so far with just sequential that operate and execute in a sequence, all right, in sequential order, line after line after line after line after line after line, and then we finish. Now we're going to deal with programs that may branch off to a certain section of the code. So that's a sequence structure, all right? I mean, not a sequence, all right? So, no, that's the first one was sequence. Now we're dealing with the decision structure. Sequence is like sequential, step by step by step by step. But now we're going to be dealing with the decision structure of coding, where we may have some sequences where we're going from one to the next, but then we get to an if logic, and then we might have to decide to go and execute one part of the code in the program or another and continue. All right. So now we're getting into the decision structure. All right. So looking at here, program. This is sequence. Only John showing you example of sequence. One after the next, after the next, after the next, and we finish. All right. So now, if we look here, here's where if we were writing code, we would have an if statement here. We may have some statements that we're doing whatever, one after the next, but then all of a sudden now it says, okay, if it is cold outside, what? Branch off, do this, and then continue, all right? Otherwise, just continue, all right? So that's similar to what we're talking about. Or you can what? Branch off, sequence, 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 then continue. So when you look at it, as you start building programs and writing larger and larger a code, you're going to see where you're going to have a combination of sequential code and then what? Decision code, where you have to decide whether or not to branch off and do this or branch off and do something else. All right. So it will be combined, all right, to where you can accomplish your task. All right. So the if statement is simple in a way that it works. If the value of the expression inside the parentheses is true, the very next statement, and I would add statements if they're grouped, is executed. Otherwise, it is skipped. All right. So now the statement is conditionally executed. That means based on whatever it yields, true or false. If it yields false, it skips. If it's true, it'll execute it. Okay, but because it only executed when that statement or that expression holds to be true. So it gives this example here with numbers. I'm gonna keep this from jumping. Let's see something. If I can. No, I don't want. Okay. Let's see. All right. Okay. Now I think I got it. Okay. It can scroll. All right. So now it won't. The pages won't be jumping. So if we look at this program here, this program set a constant high score of 95, but then it declares three integer scores and a double average variable. And in this program, they allowed the person to input 3 values using one cout statement. Once that's given, they have an expression that will calculate or sum up the scores and divide all the total by 3 to get an average, all right? They're gonna output the average, and then if the average is greater than 95, which is the high score, then it's gonna output congratulations. That's a high score. So only if what? The average happens to be anything greater than 95. If average is equal to 95, you should not get the congratulations. It has to be greater than 95. Okay? Has to be greater. So in the program, where am I? Okay, here. So I could use this and so I can say if X is greater than Y, okay, I'll say here, X is greater than Y. All right, so I'm just putting anything. X is greater than Y. All right, I could take this out. Now I could do something like see how just like that. I want in. All right, program has ended. Now watch what happens here, class. So when I run this program, okay, it outputs what? X is greater than 5 because what? Is 5 greater than X is greater than Y? If 5 is greater than 3, is it? Yes, it is. So that yield, this expression yields a 1. It performs the very next statement as the code, as the book said. But if I have my statements blocked from like an opening curly brace to a closed curly brace, it's going to do everything in that body as the yes. Okay? But if I have one statement, it'll do just that one statement. And I'll show you what I mean in a little while. So now it printed out X greater than Y. Now let me change this to this. Okay, 13. So now, looking at our code, all right, it says, okay, if X greater than Y, is that true or false? That will be false. 5 is not greater than 13. So what? It will not do this statement. Then it's going to just what? Continue with the program. So all we're going to get for the output is what? Program has ended. Okay, we won't get this. So when we run it, okay, we got it. Program has ended. Now the reason why I'm trying to stress this, watch this. If I do something like this, okay, X is greater than Y. Let me put something in here. See out. Let's see. All right, whatever. I just put something simple. Your program is executing. All right. So now, so what happens here is the program asking if X is greater than Y. But let's take this off again and make this 3. So is X greater than Y? Yes, it is. It's going to do what? Both of these statements, because they're what? They're embodied between in a curly brace, open curly brace, closed curly brace. So it's going to do everything in here, then it will continue. So let's run this, all right? Debug it, and let's run it. So I got these 2 lines, and I got this last line. Now, but check out what happens. If I say, well, I know how to code, Mr. Sylvester say use curly braces, but I don't want to use curly braces. I know it'll gonna work. This program here, if I do this, will give me the wrong output. Now you say, well, what you mean the wrong output? If I wanted these 2 statements to execute only if this is true, this is not correct. What happens here, it asks if X is greater than Y, which is false. It's going to associate this statement with this if, right? So if this is false, well, this is the true statement for this. So when this yields false, it's going to skip the very next statement, and it's going to print out your program is executing and program has ended. So let's run it and see. See what I'm saying? Your program is executed, is being displayed because you took I took the curly braces off to make those 2 statements a body to say this is what I want to do if that statement is true. So like I say, it depends on your logic for at that time as to whether or not you want these to be performed together or not. You understand? It's up to you as the user. Now, my suggestion to you is whether or not you have 1 statement or 15 statements that you want to perform after that if logic for true, always put the curly braces, right? Even if it's just 1 statement. Why is that? Well, the reason being, I'd say, whenever you have to go back and modify your program, and you got all these ifs in here, and you just use 1 lines and whatever, so it's like, okay, well, I don't need curly braces. But then all of a sudden, well, wait, I want to output this, but I also want to output this if this is true. Then now you got to try to go back and figure out where to put my open curly brace, where to end my closed curly brace. But if you do it when you first start coding, then you know, okay, if this, put your open curly brace. Anything that's in there is associated with the true part of that if logic. So you got it automatically. But like I say, it's up to you. You know, you come up with your own programming style. But all I say is be mindful, because you can run into logical problems when you are not having curly braces in the proper place. Okay. All right. So let's go back to the notes. All right. So like I say, it makes a difference where your curly braces are and how your output will look. But long as it's just one statement, it will default to that next statement. And if if this is false, it won't print this. It will just continue with the very next one. You know, if you can understand that and be comfortable with it, hey, power to you. But I would say put the curly braces just in case. All right, and it's just showing you how it's veering off. If average is greater than high score, hey, go here and perform this, and then return back and continue. All right. So if hours greater than 40, do this. If value greater than 32, do this. If overtime equals true, do this. All right. So that's all it's showing you. But as I said, I would put curly braces around this, because when you start adding more statements that you want to perform, if it's true, then you got to go and, okay, curly brace, open curly brace, close curly brace. And then you're trying to put curly braces anywhere in your program, which can cause issues. All right. So now, this is a thing, and you got to be mindful. Do not put a semicolon at the end of an if, the expression of that if logic. Now, you say, well, Mr. Sylvester, it's just a semicolon. Yes, it is. But it changes your code dramatically. And now, looking at, let me close this. And this printed just two statements, right? But now let's look back at the code here. All right. So we'll go here, looking at this. So if I do this, if I put a semicolon here, what would be my output? Anybody could tell me? Hello, class? Can anybody tell me the output? All right. This is what would be your output. X is greater than Y. Your program is executing. Program has ended. Now you say, well, why is that, Mr. Sylvester? X is not greater than 5. No, it's not. But when you put a semicolon at the end of that if, you just said, I'm closing off or stopping my if statement here. So I'm finished doing my if logic. So therefore, it does not try to say evaluate it and, oh, only do this if it's 1. Everything is done in here. So I've asked a question. I've finished it by using a semicolon. Now what? Continue with the program. You can put curly braces almost anywhere in your program. It doesn't cause problems. But you need to put them in the proper places so that your logic can perform correctly. So let's run this, and you should get all 3 output statements. Oh, it gave an error. So I did it. No, it didn't. Just unable. What it said? Unable. Oh, so it gave an error. Normally, it wouldn't give an error. It was just, let's see, debug. Yeah, okay. I don't know what that happened. So look, is X greater than Y? Is 5 greater than 13? No, it's not. But when I put the semicolon here, it says, okay, I'm finished with that if logic. Just continue on with the program. So what? The continuation is what? X is greater than Y. X is greater, then. Why y'all let me do that? Greater than Y. And then what else? And then it's going to output your program is executing, and then it output program has ended. So you see what happens? And many times students run into that issue. Mr. Vest, I'm running my program, but it don't want to evaluate my if logic. It just keep on going and executing this, and I don't know why. And you look at it, it's like a simple semicolon. All right? And then take the semicolon off, and now what? Only thing you should get now is what? Program has ended. Just a simple semicolon. And you say, well, semicolon, Mr. Vest? Yes, a simple semicolon can cause major headaches. All right, and just think if you had like 50 different if statements in your program, and about 4 or 5 of them you had semicolons after the if statement. Man, you'd be looking for errors all day long, trying to figure out what's wrong. All right, so back to the notes. All right, so it said make sure you don't put a semicolon at the end of the actual if logic, the if statement. All right. All right. So it's showing this, see? And like I say, and it doesn't give you an error. It just will give you a logical error to where it executes this statement regardless of what happens. All right. So, all right. Now, programming style and of an if, okay? Like I say, many people, like I say, they have their own programming style. Some people put a curly brace up here and whatever, just like we do the main or whatever. But it's up to you. Some people, like I say, one line, I'm going to just put that one line and continue. Like I say put the curly braces just in case you got to come back and add something logically where it need to go, all right? And you don't have to start adding things and like, oh, now it's just doing whatever. All right. So, but as I say, all that is programmer style. It's up to you as to how you want, you want to code your program and what's best fit for you. All right. Comparing floating point data. What it says is depending on the decimal place, you can lose out on a true comparison. All right. So in this paragraph, it says because of the way floating point numbers are stored in memory, rounding errors, okay, sometimes occur. Okay, this is because some fractional numbers cannot be exactly represented using binary. Okay, so you should be careful when using the equality operator. Okay, meaning the equal to compare floating point numbers. For example, in this program, in which uses double variables, which is the double data type, A and B, all right, A and B, all right, both variables are initialized, all right, to a value, okay, 1.5. Then the value 0.000 and X number of zeros, 1 is added to A. This should make the content different than B, right? Because what? It have that one whatever of a point 1, added to A. All right. This should make A's content different from B's content. All right. Because of the round off error, however, the variables are still the same. All right. So what happens is A is equal to 1.5, the of double. B is equal to 1.5 of double. Then you add it, and this, if you've never seen this before, plus equal, this just like saying A is equal to A plus this. Okay, and we need to probably look at that so you understand. You got plus equal, divide equal, minus equal, times equal, modulus equal. Okay, so you can use all those operators to do that, rather than have to rewrite A equal A plus whatever. All right. So we've added one that this long decimal value to 1. All right. And then we ask if A equal B, it's gonna say it is equal to B because of the round off issue. All right. Now, to prevent this from causing a type of problem, you should stick to greater than or even less than with floating point numbers. All right. So just say, don't ask if it's equal to, ask if one of them is greater than or less than. All right. Now, the truth. All right. So even looking at this, if value, Okay, see how is true. It is true. So it says, now you've got your feet wet with relational expressions, all right? It and the if statements. Let's look at the subject of truth again. You can see that the relational expression has the value 1 when it's true and 0 when it's false. In the world of the if statement, however, the concept of true is expanded. 0 is still false, but remember I was telling you earlier, all other values other than 0, a -1, true, a 1, true. Anything other than 0 is true, all right? So now what you can do, now you can give a variable a value and ask if it's true, okay? Give me an example. Let's go to here. So let's say, and I'll say amount. I'll just add amount. All right. And I'll say equals 100. Be anything. All right. So amount is equal 100. Now in here, I'll say if amount. So, and what we said here, if amount is any other value, any value other than 0, it will yield to it. It is true. It exists, right? So it will print this and kick out, and then it'll print this. So amount is 100. So let's run it. So see what happened? And like I said, it's kind of misleading because I didn't change the prompt to say amount is true, right? But it fell in this loop because amount was anything other than 0, and then it printed that, then kicked out and printed this. So now, so you say, well, okay, that doesn't mean that, Mrs. Sylvester. Let's make it 0. Now what? If amount, what we said, anything other than 0 is true, but anything that's 0 is false, so it won't do this, and it can fall out of here. So look, watch what happens. It's just gonna print program has in it. You understand? So that's all they printed because amount was true. But now look at this. I can even say negative, I'm gonna type any negative number, anything other than 0, right? Watch this. It's gonna print all 3 statements. See? Because what? Anything other than 0 will yield a positive or a true result. Anything that's 0 will not. All right? So now let me do this. I'll say 100. Now, watch this. I could just simply do this. If not amount. So what that means, if it's 0, right? Amount is anything other than 0. But when I do not amount, I'm reversing that logic to say 0, right? If 0. So it's not 0, it's 100. So it only gonna print this, okay? So while I run it, it only gonna print program has ended. See what I'm saying? So now, so if I put 0, so this says what? Not amount. Not amount, that's true. Because what? No, it's not an amount, okay? Which is going to yield 0. And so anything other than 0 will yield false. But we got not true. So not true is false. So false, it's going to fall into here. It's going to print all of those statements, all 3 of them. And I know this is kind of confusing, but I mean, this is computer science. This is computer science. And like I say, you're going to, as a programmer, you're gonna be writing code, and sometimes you're gonna be having to figure out, okay, if it's not this, and this is this and that. So you're gonna have to learn them operators, learn how to use them efficiently, so that you can effectively also, so that you can write code, and understand what it is you are writing. All right. So you see how the different ways we did this to get the different type of results. All right. Now, so that's why I say back to the truth and if value. So if this variable has a value in it, anything other than 0, it will output is true. If it has 0, it'll skip it and continue. All right. So looking at this, if x plus y. Now, if x plus y yields anything other than 0, then it'll print it is true. If it yields 0, like x, if it is 0 plus 0 or negative 5 plus 5, it's going to yield 0. It's going to say it's false. All right. So, well, it won't print this. It'll continue. My fault. All right. So that's how that works. So look at this. This just say if the power of a raised, if a raised to the b power, all right, true. So if a raised to any power gives you a number, anything other than 0, it will output true. So see how you got an expression here? Whatever that expression yields, if it's anything other than 0, it's going to perform the true logic. All right? But again, it tells you, don't get confused with the double equal, which is comparison, and the single equal, which is a sign. Okay? And I think we went over that where I can assign the value in order every time we run it, it just won't execute because what? If I put 1 equal, it's going to say, okay, you're assigning x to equal to that value, okay, and x is that value now, so hey, the expression is true, and I'll perform it. All right. Okay, because look here. If x equal 2, yes, x is equal to 2 because in this statement, you're assigning x to be 2. So therefore, it will always output it is true. All right, always. Because you didn't compare x to 2, you assign x to equal 2. All right. All right. So this back to that program that did the code, did the average, the 3 scores, and then the average. Okay, that's what this program is. But remember at the bottom, it did the if logic. If average is equal to 100. Now, in this statement, everybody will get a congratulatory response. Why? Because look what's happening here. This says equal, which is a sign. So when I do if average is equal to 100, I'm actually assigning 100 to average, making it 100, and then making this true, and everybody going to get a congratulations, which is what? Not what you intended, right? And you got a perfect score. Somebody made a 60, you ran through the if and said average 1 equal 100, and then you say congratulations, that's a perfect score. No, that's deceiving, right? The code is wrong, all right? So you got to watch that. Okay. Expanding the if statement. Now, this is the second part of an if that I talked about at the beginning of the chapter today. I can say if x is greater than 5, add 2 to amount. Else add 4. So now what? I'm going to do one thing if it's true, but then I'm going to do something else if it's false, all right? So you have your if logic, all right? And I think this is the part. Otherwise, I'm kind of going ahead. The if statement can conditionally execute a block of statement. Oh no, that's already talking about the block. But we talked about the block already because this whole block acts as a single statement. I'm gonna perform everything in this block. Just having a single statement, I perform. If this is true, perform that statement, kick on out. So all it's showing you, which I showed you already, you can embody your statements, whether it's 1 or whether it's 50, inside a body, so that the curly braces, so that when you hit that if and you say, okay, if this is true, do all of this, so now You're forcing it to look at all these statements by having them blocked in the curly braces. All right. So that's basically what happened. So look here. They had, see out, congratulations, see out, that's a high score, see out, you deserve a pat on the back. So if the average is greater than high score, before it had if average greater than high score, see out, congratulations, you have a high score on the same line. But now you have multiple statements, you know, semicolon, semicolon, semicolon. You put open curly braces, close curly braces, and then whatever it is you need to do. That's why I say always just put the curly braces, you're done with it. If you got to add, you add. If not, hey, they're there for future use if I have to add. All right? But you don't have to. It's all up to you. All right? Now, so, like I say, they're just telling you don't forget the braces, and I call them curly brackets. Curly brackets, because once you decide, see, to perform all these statements. Now, looking at this, all this is the same exact program minus the curly braces. So tell me what it's showing you at the bottom. What would happen if a student does not get to the highest average? This if logic, which is 100, well, or 96 or better. If average is greater than high score, oh, it's going to do this. It's going to do this. It's going to do this. And it's going to finish. Okay? So that's if there's a high average. Now, so what if a person who just did not take the test, all right, and a 0 is put in, they're going to get all the same results. Why? Well, let's see. No, they won't get the same results. They'll get, that's a high score, you deserve a pat on the back. So it's going to say if average is greater than high score, 0 is not greater than 95, so it will skip what? The very next statement, right? Because that's a part of the if by default. By default, it'll execute the very next statement if it's true, all right? So this is not true. 0 is not greater than 95. So it's going to skip this statement. Then it's going to continue on because we don't have curly braces. It's going to output, that's a high score, and you deserve a pat on the back. Okay? So you got to make sure you understand this, understand what's going on, because it can cause issues, all right? Now, so let's look at if else. This is where I was going before when it said expand. The if else. So the if else allows you to ask a question, and then if it's not one thing else, do something else. But the scenario I kind of use when we in class, when I normally be in my class, I'll tell a student, if I gave you monies to go to the Coke machine and I say, if there's a Coke, bring me a Coke. All right. Or they ask, what you want, Mrs. Beth? If there's a Coke, bring me a Coke. So logically, the student should only come back with what? A Coke or nothing, right? Because what? If there's a Coke, get a Coke, you know, and then continue on. Logically, that's it. Hey, he said he wanted a Coke. He gave me the money. Hey, there's no Coke. There's no more other instructions. I come back to class. All right. Now, but if I say, if I give them the money, then they say, well, Mr. Vessel, what do you want? I want a Coke, but if there's no Coke, get a Sprite. So the student will go to the Coke machine and look for what first? A Coke. So the logic says if there's a Coke, get a Coke. So they get there and they're looking to see if there's Coke available. No Coke, all the Coke is out. So now the student would have to do what? Defer to the second option and say, okay, he said if there's no Coke, then get a Sprite. Okay, so that's how the if logic works. If it's not this, well, if it's this, do this. Otherwise, do this. All right? So let's look at that with code. So here, I'll take the amount off, and I'll say if X greater than Y. Okay. If X greater than Y, I want to output that. Okay. But then look what I'm going to do. I'm going to say, I want that, I want this. Else program is executed. So what have I done? I said, okay. But if it's not, do this. That's all I'm saying. Do one or the other. The previous if logic said, if this, do this, and then continue. This one says, do this and continue, or do this and continue. So looking at this, X is greater than Y. That's false. X is 5, Y is 13.